Everybody, in this video, I'm going to go through our lesson key features of exponential functions. And the first thing I want to talk about is what are all of the key features of an exponential function or even functions in general. Now, the function that we have graphed here is f of x equals 2 to the x power plus 1. And if you can't draw this, print it out, just draw it as best as you can. I would just draw like an X and Y axes and then plot a couple points and draw a rough sketch of the curve. Now, first key feature I want to talk about is the y-intercept. And the y-intercept is where we cross the y-axis, where x is 0, and this is the point 0, 0. Now, our graph also has x-intercepts, which conveniently is the same point in this graph. It's not always the case. So this graph has an x-intercept. And this is where the function, or y, equals 0. And it's just coincidence that they are in the same place. The next thing that we're going to talk about in regards to this function is that horizontal asymptote that our function kind of bottoms out at. So we have this invisible horizontal line, or this horizontal asymptote. Which is a y value that our graph approaches but will never actually touch. So this asymptote is the equation y equals -1, because that is the equation of the horizontal line that sits at -1. All right, so that is our horizontal asymptote. Exponential functions will have a horizontal asymptote, and that kind of has a lot of influence on other features of our graph. Now, we know that this graph actually is increasing because as I read it from the left to the right, it is going up. So I would say this is an increasing function, and that's kind of to do with the fact that b is greater than 1. We have 2 raised to the x power. And I would say that the function is increasing, or f of x is increasing for all real numbers. And really, that's that interval from -infinity all the way to infinity, with the parentheses because we can't equal infinity. Now, if your graph is decreasing, then it is going down, and we can write it in some way where b is between 0 and 1. Now, within the function, or any function, we can relate or talk about the inputs versus outputs, or the domain and the range. So the domain is all of the x values for a function. And we read the domain, from left to right. So that way I collect the smallest to the largest value. And the domain of this function and most exponential functions is all real numbers. Or we could use that -infinity to infinity notation. And the reason the domain is all real numbers is because this is a continuous function from left to right. All right, the range is all y values and that is from bottom to top. So if I'm looking at the graph of an exponential, there is usually either a lowest value or a highest value that the graph is approaching. So in this case, the range of the graph, there is a lowest value, and that's the asymptote. We have all of the values of y that are greater than -1. Or I could say the function values that are greater than -1 are all values of our range. And that comes from the asymptote being -1. Another way I could write this range, it's all of the values starting at -1 going up to infinity. Everything above -1, notice I did not put the bracket around -1 because it's not equal to it. It's the asymptote. It's that value it's approaching, but the function, the exponential, will never quite equal -1. Now, we can also talk about the portions of the graph that are positive versus negative. Let's see, I'll use. So the function f of x is positive everywhere above the x-axis. So looking at this graph, every value that is above the x-axis on our graph is positive. This is all values where f of x is greater than 0, or our function is positive. So I'm going to highlight the parts of our graph that are positive. So our graph starts being positive at the x-intercept, where y equals 0, where the function is neither positive nor negative. And then after this point, any point that is above the x-axis is positive. So I would say that the function is positive above the x-axis for all values of x that are greater than 0. And then we would say that the function f of x is negative below the x-axis, where all of the y values are negative. So if I'm looking at the graph here, that would be everything below this x-axis, which the turning point is always going to be an x-intercept. We always switch from negative y values to positive y values at the x-axis. So all of our negative values of the function is everything less than 0. So the function f of x is negative below the x-axis for all values of x less than 0. Something else we can talk about for a function is its end behavior. And what end behavior really is looking at is which direction the graph is headed. Which direction is the graph headed? And we can really look at this two ways. We can look to the left or we can look to the right. So if we follow our graph to the left, then we are really looking as x is approaching -infinity. So the way we write this, if we're looking to the left, we are looking as x approaches -infinity. Where is the function going? The function f of x is going where? Is it going up, down? Is it approaching some value? We will fill in the blank in just a moment. So that is to the left. Now, if we want to talk about to the right, as x is getting bigger, we are going to the right. So as x goes to positive infinity, what is our function f of x doing? Where is f of x going? So there are a couple different ways we could fill in these blanks, right? As we go to the left or to the right, perhaps our graph is increasing. It is going up, or it goes up. Then I would say that f of x is going to positive infinity because it is going up. Now, if f of x is going down, then I'd say the opposite. I'd say that f of x is not going to positive infinity, it is going to negative infinity. So if our graph, as we look to the left, the function is going down, I would say as x goes to negative infinity, f of x goes to negative infinity, meaning as we go to the left, the graph is going down. And then another possibility that could happen is that our graph is approaching some value. So it approaches some y value, and we'll let this y value be k. If we're approaching some asymptote really of k, then I would say that our function f of x is approaching or going to that k value. So let's look at the end behavior of the function I have up here. So looking first at the left, going to the left, or as x goes to negative infinity, our function f of x is approaching that asymptote or that height of -1. So as x goes to the left, f of x or y is going to -1. Now let's look at the right-hand side. So as x is going to positive infinity, or as we travel now to the right, our function f of x is going up. Our function is increasing, so it is going up. So as we go to the right, our function or our y values are going up. I do want to note that your function could have some other important points. Let's see. We'll do these and make this green. So other function features. And these are considered critical points. So we could have a minimum value or a maximum. Now, a minimum is considered the lowest y value in a particular graph or even just in a particular region. So perhaps it looks something like this. Everything around it is pointing up. It goes from decreasing, decreasing to increasing, increasing. And then a maximum is a greatest or a highest, largest. Oops, did not spell that right. Great. Hello. There you go. Greatest y value. So a largest, tallest point in a particular region of a graph. Let's look at an example. We're just going to do one example with multiple parts. So the example, it is going to be given that f of x equals 4 times 1 over 2 to the x power plus 2. And I do have a graph of this. If you can't print it out, just draw a rough sketch in your notes as best you can. And we're going to answer a couple different questions with this. Number 1. Oops. What is the equation of the asymptote? So if we look at the equation here, the asymptote I actually could get just from the f of x equals 4 times 1/2 x to the x power plus 2. Or I could look at the graph, and the asymptote really is kind of like the tail end of the graph that bottoms out at this height of 2. So this asymptote is the equation y is equal to positive 2. And we see this as this plus 2 at the end of the equation. Number 2, what is the y-intercept? So looking where we cross the y-axis is the vertical axis, and we cross the y-axis at the point 0, 6. So our y-intercept, I would say, is 6, or it's the point 0, 6. And this has no x-intercept because that asymptote at 2. C, or no, 3. What is the domain? And this function, we see just a snapshot of it, but we know that it is continuing on forever and ever and ever. So we have all of the values from negative infinity on the x-axis, right? Because this is really the x-axis extending from negative infinity all the way to positive infinity. So every x value that you can think of is somewhere on this graph, and we could find it. So the domain is all real numbers, which sometimes we see this all real numbers represented as this fancy R, or we could again write this as negative infinity to positive infinity as an interval like so. Number 4, what is the range? Now the range of an exponential, remember, it is dependent on the asymptote. And in this case, the asymptote of 2 is the lowest value that our function has. So if I'm looking at the y values, I'm going to read this from the bottom to the top. And the lowest y value that I have is this 2. And then I have everything above that. So our range is all values of y that are greater than 2, or f of x that is greater than 2. I also could say that it is all values starting at 2, but not actually equal to it, so I'll put parentheses, up to infinity, which we can't equal infinity, so parentheses around that as well. Number 5. Do that over here. Describe the interval of increase or decrease. And if I look at this function here, I notice this function is from the left to the right going down. So this is decreasing, and it will never stop decreasing. So I will say this is decreasing on the interval negative infinity to positive infinity, or for all real, numbers. We will do one more problem for this graph, and then that is a wrap. So number 6, describe the end behavior. An end behavior always has two parts. So first, we are going to look from the left, or as x goes to negative infinity. As we go to the left, what is the function doing? So let's follow our function to the left, which means we actually need to start on the right and look. Oops, I didn't really mean to do that. Look to the left, and I notice I would be going up. So as I follow my graph to negative infinity, our graph is going, oops, what just happened? All right, so as x goes to negative infinity, our function goes up or goes to positive infinity. And as x goes to positive infinity, or as we go to the right, forgot to say that this everything means up. As we follow our function to the right, to positive infinity, we are bottoming out at this asymptote of 2. So that is the end behavior on the right-hand side. As x approaches infinity, f of x is approaching 2, that asymptote. Please let me know what questions you have. These can be some tricky concepts. You can always send me screenshots of problems you're stuck on, and take a look at the extra help videos I have in our course as well.